Hello, and welcome back to the Pi Data track of the Python Web Conference 2021. With me this morning, well, my morning, his afternoon, is Alexander Hultnér, calling in from Sweden, from Gothenburg. And he is going to speak to us today about an introduction to Pydantic for runtime checking, type checking for your data classes. Over to you, Alexander.
Yeah, thank you. Yeah, so I'm calling in from Gothenburg, Sweden. I just came here that we've had like a mix of sun and rain today. So if the light conditions flicker a bit, it's because we got very mixed light here today. But anyway, so I'm calling in from Gothenburg. It's afternoon here, so I'm almost wrapping down my Friday. So it's nice to end with this conference. So Pydantic is what I'm going to talk about. Runtime type checking for your data classes is the subtitle, but it's actually more than that as well. And you'll see that in this talk today. So first, a little bit more about me. So I'm Alexander Hultnér. I love to speak at conferences. I think I've spoken at almost 10 conferences in the past year now. And I'm also the founder of my own company, Hultnér Technologies, as well as Papero.io, which is a SaaS service for turning web pages into PDFs, basically. So everything from receipts to we do like shipping slips and stuff like that. And we're just launching that business now. We built it last year and started to launch it late last year. So if anyone is interested in that, you can contact me later. We are taking on early customers now, so it's kind of invite only, but you can sign up for the wait list. I'm not gonna talk more about that. But anyway, so all the links in all my slides, I have a lot of links, and every time you see something blue like this, then it's a link, and I always make sure that they are clickable. And you can go to slides.com/Hultnér, and on the top you will see the slides for this talk, and they are already up. So I developed my slides in public, and basically you can find all the links and click everything there. So you don't have to remember that while watching the talk. You can focus on what I'm saying instead. So let's continue then. So outline of today's talk then. First, I'm going to start with a quick refresher on the Python data classes, just so we all are up to speed what it's about. And then I'm going to introduce you to Pydantic. I'm going to talk about a little bit about some prior art, other tools that have done similar things before Pydantic. I'm going to show you a minimal example of how you can use it with their own data class decorator. I'm also going to showcase some runtime type checking, which is probably what you will find most interesting. But then I'm going to go into some JSON stuff. You have things like JSON serialization and deserialization, as well as JSON schema built into Pydantic. So that's also quite interesting. I'm going to show you some custom validators, show how you can integrate your own business logic into your models, and also show you how you can use it for function arguments. So it's not just for data classes, it's actually useful for all functions. I'm going to talk a little bit about some other things as well, like framework integrations. So what's really nice about Pydantic is that it's been very well adopted, and a lot of frameworks have either first-party or third-party integrations, and some of those are Flask and Fast API, Django and more. Quart, which is async version of Flask, has it as a first-party plugin as well. And I'm going to talk a little bit about open API specifications and how you can use all this to also auto-generate tests for your code. And of course, I'm not gonna be able to cover everything because Pydantic is very easy to get started with, but there is a lot of cool features in it. So I'm gonna just name drop a few of them that you can look at later in the end, and then we're gonna have a conclusion and of course a Q&A, so you can ask me some questions. And with no further ado, let's get started then. So for today's talk, I'm going to use an imaginary cafe as the example types. So I'm thinking about a waffle cafe called the Waffle Bistro, because it was the International Waffle Day yesterday. Some of you may know it. Me as a Swede, where it comes from originally, of course, keep track of the International Waffle Day. So I had too many waffles yesterday night. So anyway, let's start with the quick data class refresher. So here we have our waffle data structure in the waffle class. We have a style of waffle. For instance, is it a Swedish waffle, a Belgian waffle? And of course, no waffle is complete without toppings. So it's a tuple of strings as well. This is basically the minimal you can get away with to model this waffle. And I'm going to keep all the code examples quite small, and everything isn't going to be the most pretty formatted because I need to fit it on the slides. So I hope you understand that these aren't always perfect examples of how you should do in production, but the features are the same. So let's try it out then. Let's create a Swedish waffle. Now let's put some strange combination of toppings on this. So I'm going to put chocolate, sauce, and ham. And since we haven't put any restrictions on this, we just have strings. It's going to accept it. So now we have a waffle with chocolate sauce and ham, and it's Swedish style. Of course, this maybe isn't something the Waffle Bistro really wants to sell. So maybe we should constrain the toppings and the styles we offer. And for that, we can use enums. So we offer a couple of cream-based toppings and a couple of dessert sauces. So let's see what that could look like. So here we have a cream enum, and we have whipped cream and ice cream, the obvious choices for your waffles. And of course, here we have a couple of dessert sauces. I'm going to keep it quite tight just to fit all the code, but I have cloudberry jam, my personal favorite. It's a orange raspberry looking little berry, but it's much better in taste. It's impossible to explain, so you have to try it out sometime if you haven't. And raspberry jam, also a classic, and chocolate sauce, which is popular in the Belgian style from what I've heard. So the toppings then is a type that's the union of dessert sauce and cream. So this is just a type alias. And then we have our waffle style, which is also an enum. And for our cafe, we're going to have Swedish and Belgians. And then we're going to just change our types for our data class to style waffle style. And the toppings is now a tuple of toppings instead of strings. So let's see if we try what happens if we try to create a waffle now with ham topping. So as you see, nothing really happened, and we still get the Swedish style with the ham, which shouldn't be allowed. And we can see that these are actually still strings. So we're actually not enforcing these types in the runtime, which can be a problem if you have data from a third-party source, or for instance, user input data or something like that. So we probably want to marshal these types in runtime and make sure that we get the correct things. And this is where Pydantic comes very good in hand. So a quick introduction to Pydantic then. It's a Python library, of course. They have really great documentation. I love their pages. So there's a link here, and just go to my slides at slides.com/Hultnér after the talk if you want to check it out, and you have those clickable there. So we have data validation using Python type annotations. So the code looks just like standard Python, nothing special, no like super involved things to get started. And we have runtime type enforcement, which means that we will always be sure that we have the correct types when running this code, and that we can't get the case we saw with the waffle here. There's no convoluted syntax, as I said. It's just pure Python classes and types. There's support for both serialization and deserialization, for instance, pickle and JSON, which is very handy when working with it. There are some predecessors, and of course, I'm going to mention Dataclasses, which is one of the greatest advances I've seen in modern Python versions. And then we have things like adders, which I kind of see like a precursor to Dataclasses. And we have things like Marshmallow and Validator. There's also a lot of ORM libraries that provide some runtime checking. So kind of these are the things that came before that made things like Pydantic possible. So let's go ahead then. Pydantic with runtime type checking then. So let's write the data class drop-in replacement. With data classes, as you saw, the types aren't enforced. And this can, you could of course implement this yourself. I've actually done this, but I mean, the basic case is not that advanced, but it quickly gets very tricky. So let's instead lean on the shoulders of the giant Pydantic. And let's look at an example then. So now we import data classes from Pydantic instead of from the standard library data classes. This is basically the only thing we need to change in our prior code to get the most basic use case of this. So very easy to get started with. And now I'm going to import the validation error from Pydantic. And let's see what happens when we create the waffle with ham this time. Now, as you can see, we get a couple of validation errors. Basically, it's saying that the topping we choose, the ham, at the location 1 is not a valid enum member either of the dessert sauces or of the creams. So chocolate sauce was accepted, but the ham wasn't. So with that simple change, we can see that the new instance of an unsupported waffle actually raises an error. And this error also contains a lot of useful information to understand why it didn't work to create this waffle. So I really love this, and the errors are super readable. And they are even more readable if you're not on a small slide like this. So that's like one of the best things, I think. So you should really, really take a look at that. So let's continue then. Okay, so maybe we should try to create a valid waffle then, so we can see how that would look. And this is Cloudbearers actually. So if you see these, it's probably Cloudbearers. So we're gonna create a waffle with whipped cream and Cloudberry jam. Note that I use the enum instance directly in this case, while here I just reference to the string value that the enum uses. Same here for the Swedish. And let's see what happens when we create it. So as you can see, we get a waffle, and we see that the waffle is a waffle style Swedish. And we can see that the toppings are cream, whipped cream, and the dessert sauce is Cloudberry jam. So as you can see, the Cloudberry jam, and actually the waffle style as well, is automatically parsed as a dessert sauce. And this makes it very easy to work with when you parse external data and you want to get it into your own data structures or types. So for instance, when working with JSON, this is very useful for me. More strictness can be achieved with the strict types. So there are a couple of strict types that doesn't coerce types like we see here. And there's also being some work made on fully strict mode, issue 1098. I will add a link for that here as well. I was actually going to put that link, but I forgot to put it in the slide. But that is probably coming in the future or not too far away. And if you need to disable this coercion, you can do it by using strict types at this moment as well. So as you see, it's very, very easy to get started with. And now we actually have a valid waffle with the types we want. So what about JSON then? We talked a little bit about JSON, and of course I'm going to show you what Pydantic can do in this regard. So we have the data class drop-in replacement, which is great for compatibility. You just need to change the import and you can get started with your Pydantic classes. You don't really need to change any code, but maybe you want to do more. And when you go further, you probably want to use the Pydantic base model instead. There is actually not much difference when starting. So as you see here, the only thing I changed was that I removed the @data class decorator and instead inherit from base model. But by doing this, we get the serialization and deserialization, and we also get first class JSON support, as well as a lot of other things. So this is how I'd recommend working with Pydantic when you go beyond just replacing your existing data classes. But there are some things you should think about when you use the Pydantic base model. There is some difference. I'll get more into that later. So let's see then. One of those things that's probably most important to think about is that we should specify our arguments using keyword arguments when using the base model. So I'm doing the same thing. I'm just using keyword arguments here for style and toppings. And we get the same waffle, as you can see. But now we also additionally can easily encode this as a JSON object. So there's also built-in support for dictionaries, pickle. There's an immutable copy function, and Pydantic will also deserialize subclasses, so you can have a deep structure of classes, which is very useful. So now we have the object. So the underscore here just references the last row, and I run the JSON function on it, and as you see, we get a very nice string out of it, where we can see that we have a Swedish style with the toppings, whipped cream, and cloudberry jam. So this is very useful when you want to transfer this to, for instance, front end if you use it in an API, or if you just want to serialize it to some external system. Then maybe we should see if we can reconstruct our original object using the JSON. Otherwise, it's not that useful. So let's do that then and see what happens. So to do that, we'll use the Parse Raw function, which is also built into the Pydantic library. So when I do the waffle.parse raw and input the JSON string there, we can see that we get the same waffle object out that we put in from the start. And you can also parse lists of objects. There's a parse function in the Pydantic library for that. I'm not going to go deep into that right now, but it's good to know if you want to do that. So let's continue then. Errors then. Errors raises some validation error, as I showed you before. But these can also be represented as JSON. And this is especially useful if you want to communicate with external systems, or you want to build an API, or whatever you may want to do. So let's do error.json this time and see what gets out of it. And this time I actually changed the style to 42. I should have highlighted this. So this is an invalid style because we don't support the style 42 waffles. But as you can see, we now get a very nice structured error message where we can see that the location of the error is in the style property. We can see the message that the value is not a valid enumeration member, and we can also see the permitted members, Swedish and Belgian. And then we can see that we also get a type of the error, and we get a context where we can actually see the valid enum values. So I've used this to create tooling in, for instance, front-end code, where I can show, for instance, in a form exactly where the error is and show what would be the legal values or what you did wrong. And you can build a lot of cool things automating how you handle these errors based on that. So that's something I really like about Pydantic as well. So let's go ahead then. So JSON schema, some of you might have heard about it, but it's used in OpenAPI specifications, or Swagger as it was formerly known as. And we can export a JSON schema directly from our models. So as you then understand, you can feed that to anything that can generate a Swagger OpenAPI spec. Usually you don't have to do this yourself because a lot of tools are already built that will do it for you. But I'm going to go deeper into that later. So let's look at the Waffle schema then. And as you can see here, we actually have a well-formatted schema defining how the Waffle should work, which follows the JSON schema standard. So there's a lot of tooling you can use to put this into another system based on this. One thing you should keep note of is that Pydantic uses the draft 7 version of JSON schema. OpenAPI just released a new version of their spec, which is 3.1. It was, I think it's almost exactly 1 month ago now. So the old 3.0 spec is still very common, and that uses draft 4. Just some minor things that I've seen that's incompatible or can be problems, but it's worth keeping a note of. I've talked with Samuel, who created Pydantic, about this some while ago, and his recommendation basically, if this is a problem for you, is to write a schema extra function and use the older JSON schema version if you want strict compatibility. For instance, the Fast API framework doesn't do this, and have been using the slightly incompatible version of JSON schema with their OpenAPI specs before 3.1 was released in their 3.0 versions. So for most of you, you're probably never gonna note it, but I've noticed it a few times. So basically, yeah, this is the JSON schema version of our model. So let's go ahead then. Validators. So now I'm going to talk a little bit about custom validators. So you saw the built-in ones that validates the types in runtime, but sometimes you have some extra marshalling you want to do, or some extra business logic or rules you want to enforce. And this is where you can get some really nice behavior out of Pydantic. So let's go ahead and look at this example. So now I import validator and root validator from the Pydantic library. And I want to implement some custom business logic based on our the Waffle Bistro place. So I've added 2 validators. I want to check the topping style, and I also want to check the creams. I will get into why, or what our rules are. So first, for Swedish waffles, we only want to support jam as a topping. So we don't want the chocolate sauce on the Swedish waffles. And as you can see, I get all the values from our model here into my validator. The pre-equals false here says that the validator should run after all the other have run. So it's putting it, last. And if you would set pre-equals true, it will be a pre-validator being run before you instantiate your object. So I get out my style and toppings, and I check that the style is Swedish, and I also check that all the toppings of the type dessert sauce is actually in the Swedish toppings legal list here, the white list I've kept. And if this would fail, and it also fails the Belgian check later, it will raise a value error saying the Waffle Bistro doesn't sell this waffle. Basically, so this is a very easy way to check several attributes at once. So I check both the style and the toppings and make sure that they adhere to some common thing. So after that, we want to check that the Belgian waffles use the Belgian toppings. So for the Belgian toppings, we have the chocolate sauce. And then we check that all the dessert sauces in the Belgian toppings belong to the Belgian toppings. And also the same thing, if it doesn't match, then it will raise a value error. And lastly, we want either ice cream or whipped cream. So now we have a check cream. This validator actually references a specific field, as you can see here. So the previous one was a root validator. It references the entire object, and this references just the specific topping property. And for this, we're gonna get all the creams from the toppings. So check, get a small list comprehension, just checking which are creams, and then I'm just gonna check that there's not more than one cream in this, because we don't support both ice cream and whipped cream at the same time. And if there's more than one, we'll raise a value error saying that only one cream is allowed, and also show the user which creams they gave us. And if everything passes, we return the toppings and the object is instantiated. And all the code as well is in a Jupyter notebook book on my GitHub. And you can find those links as well from the slides, so you know that for later. So let's see if we create some invalid waffle orders then. Yep, so we have our new waffle order. So this new object was a waffle order, which actually makes sure that it's one of the styles that Waffle Bistro supports. And now we want to create invalid orders. So I'm going to create a Swedish waffle with ice cream, whipped cream, and cloudberry jam. And we didn't support both ice cream and whipped cream. So we're expecting an error here. And as you can see, we get 2 validation errors for the waffle order. So you might wonder why we get 2. And this is because of how we implemented the root validator. And basically the toppings run first. So our validator validating just the toppings is the first one being run. And when it's being run, it's seeing that we actually have more than one cream. And because of this, it's not gonna let the toppings actually be set. So when the root validator later runs, it doesn't have any toppings. So that's why we get a non-type here. It's basically because when it's trying to get the toppings here, it gets none. And of course, you could have some checks around that to get nicer errors, but for this example, I think this is good enough. So let's go ahead then and try to create another invalid waffle that tests the other validator we had. So now I'm going to create one with both cloudberry jam and chocolate sauce, and it's a Swedish waffle. So chocolate sauce shouldn't be allowed. And this time we get the error from the root validator saying that the Waffle Bistro doesn't sell this waffle. So there you have your custom business logic in 2 functions basically added to your logic. So let's go ahead. Yeah, so functions. So as I told you before, you can use Pydantic to validate functions as well. So we have these very useful runtime type checkers. And now we want to use it with functions. Then we have something called validate arguments, which is a decorator in Pydantic. It was added in version 1.5, and it's still considered beta. It was released back in 2020. Not much have changed, but you should keep in mind that it can change when the 2.0 version gets released. So you know that. But basically, you can add this validate arguments decorated to your functions. And here we have the make order function, which does some undefined thing, which I haven't put in here, but just to show. And we have the validate arguments. So this is going to validate that the input to make order function is actually a waffle order. But we can still input JSON and it will get parsed, or not JSON, this is a dictionary. So this time I'm gonna try a breakfast style waffle, but of course, as you already know, we only have Swedish and Belgian style, so we don't have breakfast waffles at this point at the Waffle Bistro. So now we can see that we both get the error saying that the waffle bistro doesn't sell this waffle on the root validator. And on top of that, we also see that the style is not a valid member of the styles we serve. So there you have it. It's basically the same thing. And this would, of course, work with like another type that isn't a Pydantic model as well. So you could have like inter or string or list of strings or whatever, and it would validate that as well. Just so you are aware about that. So let's go ahead and talk a little bit about framework integrations then. So Pydantic driven APIs is a thing that I think is here to stay. Some really nice things that's common with these is that they have automatic specs, so open API specs for those who are REST-based, and GraphQL have their GraphQL schemas. We get request and response validation, so we get runtime validation of all the data that passes through our system. And here's a couple of tools that can do this. So Spectre is a framework agnostic implementation that can be used with both Flask, Falcon, and Starlet. I've used all of these libraries, so it's very nice that something that works with all of them exists. Another example is Quart. Those of you who don't know about Quart, it's async Flask re-implementation by Phil Jones, PG Jones. And it's basically the Flask API, but in async. And Quart have a first-party Pydantic integration called Quart Schema, which is very nice as well. It's very similar to the other implementations. And Fast API, a lot of you have probably heard about it. It's been gaining a lot of popularity lately. It's also a Starlet-based framework, and they basically have Pydantic as a first party and first class citizen in their framework. So it's basically built for using Pydantic from the ground up. But how you use it in Fast API and in Quart Schema and in Spectre and also in Django Ninja, which is a Django integration, the way you use it is super similar. So I'm going to show you an example from Fast API, but it's almost the same code if you use it in another framework. So that's really nice because that makes our data models portable, so we can use them in a lot of different code bases. Maybe someone wants to use them in Django or use them in Fast API, or maybe you're migrating from one framework to another or some other thing. So that's one thing I think is really nice. And then we have Strawberries. I don't know if you've heard about it, but it's a GraphQL framework for Python, which I find quite interesting. And they have also Pydantic support. It's still experimental, but it's there. And I've seen some other as well, like for Graphene, I've seen libraries integrating it. And I think, I mean, if you just Google it, you will find a ton of implementations. So these are just a few that have stood out for me that I've looked at before. So yeah, I put this puzzle picture here because it's kind of like a puzzle piece that fits into almost all frameworks and feels very natural when working with APIs and things like that. So let's go ahead then and talk a little bit about automatic testing. So this isn't just for APIs, but we have Schema Thesis. It's particularly for APIs, and Hypothesis plugin can actually be used with any code that uses Pydantic. So I've used it in a lot of places where you don't use API or use the models in APIs. I use Pydantic for a lot of things these days. So PG Jones, the creator of Quart I talked about earlier, wrote an article about automatic API testing with the Hypothesis plugin. He uses a very similar technique that I use myself, and I've talked with him about this. It's a great article to get started. So I recommend reading that. But basically, everything you need to know if you know anything about Hypothesis is basically you have your argument, and then you can use strategy.builds and then your model reference there. And if you don't know how to use hypothesis and want to learn more about that, I had a talk at PyCon Sweden 2019 where I talk about that, and the link to that video on YouTube is here, so you can learn more. Then we're going to talk a little bit about Schema Thesis. I talked a lot about Schema Thesis last year. I'm probably going to talk about it more this year as well because I love it. But it's a library that reads in an open API or a GraphQL specification and then generates automatic test cases based on that. So basically looks at the schema and makes sure that your API actually adheres to everything that's in the schema, makes sure no exception is thrown, or that you get no 500 or something like that. I have a talk from EuroPython last year that's linked here, where I talk about it, which I recommend watching. I have a couple of other talks on it as well, for instance from FlaskCon, but it's very similar, so I'd recommend to just watch this one, or anyone if you want. Okay, so let's go ahead then, and I'm going to show you a little example of how you can build an API using these Pydantic models. This is going to be quite minimal, but basically I'm going to use Fast API for this example, and it's a lean micro framework, very similar in spirit to Flask, and it supports automatic open API specs out of the box, very tightly integrated with Pydantic, and it's an async ASCII framework, but you can use it with synchronous code as well. This is everything we need to create a small API around our models. So basically, we have our functions here that are our internal business logic. And then I just put this app .post, and I put the route I want to access it from. And then I put the waffle order type here, and it will be used for the body. This is basically everything you need to have a very simple API up and running. And of course, this code is in the slides as well and in the notebook if you want to try it out yourself later. So yeah, I wanted to show that just it's super easy to create APIs that are very polished when you have this. So that's just the beginning. And this is just a quick introduction to Pydantic. I can't cover everything in this talk, but it's the tip of the iceberg, and I still want to give you a hint about what more you can do with Pydantic, and you can feel free to ask me about it in the chat or on Twitter or via email or on LinkedIn or wherever you want. And basically here is like a quick taste of some of the things I like that I've used, and it's post 1.0. It reached this milestone back in 2019, so it's been stable for quite some time. Supports standard library types, and there's a lot of useful extra types that you can use in your everyday use. So you have, for instance, an email type, you have URLs, you have Postgres DSNs, you have IP addresses, you have positive integers, payment card numbers, constraint types. Those are really useful, so I recommend checking them out. You can subclass, for instance, constrained int, and then you can set a maximum minimum value and stuff like that. Strict types without coercion and more. Support for custom data types, settings management. This is super useful, so it can read environment variables from your env or .env. We have an ORM mode, so you can load from ORM models directly. Supports recursive models. You can do field customizations via the field function. There's support for annotated types. You can use with field as well. MyPy support. There's a great MyPy plugin that also further improves the experience. You can use postponed annotations and in self-referencing models. Python DevTools integration for getting nicer output. There's a PyCharm plugin, which I haven't tested, but should be nice. It's very fast compared to a lot of popular alternatives. But if performance is critical for you, you should always do your own benchmarks. But you can check the public benchmarks in this link as well. So conclusion, we have the pure Python syntax, so nothing really like unique or special in that way. So it reads very easily and you get better validation, very useful JSON tools for APIs or for working with external data, easy to migrate from data classes or back if you need to, lots of useful features, always more things coming, very active development. There's a strict mode being worked on, and you should just try it out. I mean, just play around with it and you will get a great feel for it. So if you have any questions, I hope I have some time for that now. And if you want to learn more, I'm also available for training, workshops, and I do some freelance consulting via my company. I have a hypothesis course I'm working on for automatic testing. So if you click on this link, I can send you an email once it's done. The Papiro beta is open. There's a link earlier in the slides. And some other links. Here's my Twitter, my email if you want to contact me, my GitHub, and here is also the link to the repository with all the content from this talk today and all the code and everything. My website, the slides, and my LinkedIn.